Good afternoon, everyone. A warm welcome to all participants for today's FDP session. This faculty development program is being conducted by Department of Artificial Intelligence and Data Science under the theme AI in Healthcare, Data Analytics, Ethics, and Real-World Applications. As we move forward into the third day of the FDP, it is encouraging to witness your consistent participation and interest in this learning journey. I sincerely welcome each of you and hope today's session will be both informative and encouraging. Today's sessions we will focuses on AI in robotics for healthcare. In this session, we will explore how the integration of artificial intelligence with the robotics is transforming healthcare by improving accuracy, enabling automation, and enhancing patient care. This session will also highlight real world applications such as robotic assisted surgeries and smart healthcare systems. We are delighted to have with us today an experienced resource person, Mr. Jitin Casey, Assistant Professor in Department of Artificial Intelligence and Data Science, Jyothi Engineering College. Mr. Jitin Casey holds both MTech and BTech degrees in Computer Science and Engineering. He is a recipient of Institute of Scholar Young Research Award 2021, and he is also a member of NVIDIA Developer Program. He actively contributes to research community as a reviewer for IEEE Access with expertise in cutting edge areas such as explainable AI and cyber attack detection and robotics. He has also served as an editor for the book Intelligent Security Systems, Data Privacy, Cryptography, and Cyber Protection. His research contributions include publications in reputed platforms like IEEE Explore, Elsevier, and Springer, covering the domains such as AI security, cryptography, IoT security, and optimization algorithms. With his rich academic and research experience, we are confident that today's session will be highly informative and insightful. Let us warmly welcome Mr. Jidin Casey. Sir, you can start the session now.
Thank you, ma'am, for the introduction. Okay. I will share my screen. Good afternoon to all. My name is Jidin. I'm a student professor, Department of Artificial Intelligence and Data Science, Jyothi Engineering College, Kerala, India. Today, I'll be presenting on the topic AI in robotics for healthcare. In this session, we will explore how artificial intelligence is transforming robotics and how these technologies are revolutionizing the modern healthcare systems. Let us begin with a fundamental understanding. First one, automation and robotics. And what is automation? The automation is refers to use of technology to perform tasks with minimal human interventions. It can be software-based or hardware-based or something, or automated data processing systems. On the other hand, robotics. Robotics is a specialized branch of automation that involves physical machine capable of interacting with the real world. In healthcare, robotics goes beyond automation by integrating sensing, decision-making, and physical action, often powered by AI. Okay, this is a basic understanding of automation and robotics. Okay, moving on to next slide. The father of robotics is known as Joseph Engelberger. And if you are developing a robotic system, you must follow these Isaac Asimov's laws. And these are the basic principles or basic law we have to follow to develop a robotic system. And the first one is protect, and the second one is obey, and the last one is survive. Okay, these are the basic three laws of for developing a robotic system. Okay. Then, as we integrate AI into patient care, we must ground our development in ethics. we often refers to Asimov's law, especially the zeroth law. A robot may not harm humanity, or by inaction allow humanity to come to harm. In a healthcare context, this is just not a science fiction. It is the foundation of patient safety and do not harm. Okay. There are many types of robot you may be familiar with, such as those used in agriculture and aquatic and industry, space, and healthcare. Okay. And in most robots, basic structure is a manipulator arm. The manipulator arm is a reprogrammable multifunctional mechanical device used to perform various movements and perform some task of the robot. Okay. This figure illustrates the basic structure, which is equivalent to the movement of human hand. Okay. These are the basic parameters of a robot. If we are developing or simulating a robot, we need to understand these parameters, such as degrees of freedom. This is usually the same as the number of axes here, the links and joints and working envelope, the region of space the robot can reach, and the kinematics, actual rigid members, and the payload, how much weight can be a robot can lift, and speed, acceleration, accuracy, etc. Okay. And now that we understand the basics of robotics and automation, let us look into the how robotics is applied in healthcare. Okay. In healthcare, one of the most prominent example is Da Vinci surgical system. Okay, you may be heard the surgical robotic surgery based on this Da Vinci surgical system. It provides high definition 3D visualization and tremor-free precision, enhanced flexibility compared to human hand. This surgeon does not get replaced. Instead of, the robot act as an extension of surgeon's capability. And this leads to reduce the surgical errors, faster recovery time for patients. Beyond surgery, robotics also play a crucial role in patient recovery and assistance. Okay. So for that, we have rehab robots and assistive robots. Okay. Rehab robots are used to help patients in region lost function through repetitive and controlled exercises. These are especially useful in stroke recovery and neurological rehabilitation and physical therapy, etc. like that. And assistive robots are designed for long-term support. Okay, they help individual with disability perform daily activities such as walking assistance, feeding, personal care. Okay, these robots significantly improve quality of life and independence. Another important category is hospital delivery robots, also known as autonomous mobile robots. These robots are used to automate logistics inside hospital. They can deliver medicines and um, transport lab samples, move medical equipments. This reduces workloads on healthcare staff and minimize human contact, which is especially important in infection control scenarios. Okay. So these are the basic introduction for the robotics in AI. So now we are going to discuss about important tools and framework platform for developing AI-based robotics development. Okay. These are the overall topics we are going to discuss. Cloud-based AI means Google Cloud, BioNemo, and Copilot, etc., etc. So we're starting with Google Cloud. Okay. So Google Cloud is a free cloud-based platform that allows you to write and execute code directly into a browser. If you are a beginner or fresher in healthcare and robotics-based AI platform, so you can use the Google Colab platform. Okay, so in Google Colab platform, you can develop simple model like a machine learning model for your healthcare project. For example, if we are categorizing the medicine based on their image. Okay, so based on the image we give that we need classify using some model, we can develop Google Colab, meaning using Google Colab, we can develop some model, machine learning model to perform this task. Okay, so I will give you some example for that. So, okay. Here is a medicine classification example, okay, using Google Cloud, I developed a code. Okay, the code execute a creative machine learning model to predict which tablet or which categories of tablet that you have given to the machine learning model. Okay, here I am using some data set and classify the medicine tablet A, tablet B, up to tablet J. Okay, I built a model using CNN, convolutional neural network. Okay, and the model name is called machine learning model.h5. And here you can see that I saved the model machine learning model.h5. This machine learning model is used to identify or predict what type of machine, what type of tablet that we are using. Okay, so for that I used again the medicine model.h5 model to predict what type of medicine that we are using for based on the image. Okay, so I will show how this code's working. Here you can see that the prediction is based on the images that we are uploading. Okay, so based on this image analysis or the prediction result, the confidence is greater than 0.7. That means 70% is greater than, then robot will take an action to pick that medicine. So we can use this machine learning model to robot pick some medicine or pick some tablet for the patient. So if less than 0.7 confidence, then human verification is needed. Okay, so here we can see that we can choose a file from. Okay, I'm choosing some file, tablet images. You can see that, and choosing first one. This is my tablet image. You can see that the confidence rate is 92.68%. Then the result is robot action. Pick tablet J. The tablet category is J, so robot can take action to pick that medicine. Okay, so again, we have to check with another image. I'm using this medicine tablet. Here you can see that 60%. So it's less than 70%. So low confidence verification is needed. So human verification is needed here. Okay. So this is a simple machine learning model to predict the classify the medicine based on the category. Okay. So you can, if you're a beginner, you can use this code or use this machine learning model to improve the healthcare operations. Okay. For the robotics. Okay. Then next one, Gemini Robotics. Okay, the Gemini Robotics is a vision language model that brings Gemini agentic capability to robots. It's allow robotics to interpret complex visual data, performing spatial reasoning and plan action. Okay, so in here we Gemini Robotics is an AI-based AI model that allows you to integrate with AI and robotics. For example, if you have a surgical tools planning their arrangement in operation or such a hospital, it can be used by a robot. Then Google Gemini Robotics will help you to plan these organization to a robotic field. Okay, so sample example, if identifying a surgical tool and planning their arrangement, we have to give an input surgical tray. Based on the surgical tools and tray, the Gemini Robotics will identify the position and what are the plan to move, how to move a robot, and how to pick that robot tools to arrange the correct place. Okay, so for that, we have to integrate Google Gemini Robotics with our project. So I will show you some example. Okay. This is Gemini Robotics. Okay, every user, every normal Gmail user can sign up with try Gemini Robotics. Okay, you can get a dashboard like Google AI Studio dashboard. In here, you can create a simple API key here. Okay, based on this API key, all the operation can be done. Okay, I already created a API key here. Okay, you can see that. Okay, so I integrate with Colab, Google Colab. Okay, here you can see that I integrate with Google Cloud with that API key. We can use that Gemini Robotics API. Okay. So in here, let's consider an example. Uh, Identify the surgical tools and planning their arrangement. Okay. So here you can see that I am uploading in an image surgical tray.png. Okay. The image, you can see that the image, okay, surgical tools. Okay, and here also surgical tray. Okay, these surgical tools arranged by a robotic system. Okay, so for that I am uploading this surgical tool image into this card. Okay, so surgical tray.png. I already uploaded this image. So executing this code, you can see that Gemini Robotics will give complete planning structure for the robot. Okay, the step one, planning and orientation, how to approach and grasping, clearance and handover transfer, how to transfer, handoff confirmation, and all the information for the robotics will give the Gemini robot. So if you are using AI plus integrated with the robot, the Gemini robotics will be the better option for developing. Okay. So let's do with another image. Another image names sur.jpg. You can see that this image, sur, this image. Okay. For this image, how a robot system arrange these surgical tools. Okay. Okay. sur.jpg. So I'm going to execute this code. You can see that based on the image, the robotic plan will be changed. Play phase one approach and alignment and the position located in the positions, the tools located in the position and transferring and all the details have been given by the Gemini Robotics AI. Okay. So if you are planning robotics with AI integration, you can use this Gemini AI robotics. It's a free tier. Currently, I'm using free tier. Okay, you can use the free tier or paid version. Okay. Then next one, open AI models. OpenAI providing different AI models for our project. Okay, we can see that image and vision, audio, speech, and coding, expert, responsive API, etc., etc. Okay, so based on the requirements to the robotic system, if you want to image and vision, so OpenAI will providing different types of AI models. Okay, you can pay and integrate with your project. Okay. So there are different lots of AI-based AI models here. You can integrate with your project. Okay. The next one, all these three, OpenAI and Gemini, Google Colab, all these are need to user need some knowledge about the coding or developing. Okay, for the non-code users. You can use orange data mining. Okay, if you are not familiar with coding, okay, you can use orange data mining for AI operations. Orange data mining is an open source visual programming software that is used for visualization, machine learning, and data analysis performs. Okay, you can use the orange data mining software can be used by user for UI based and drag and drop method operations. Uh, So we can, I will show you an example. Okay. This is a site of Orange Data Mining software. We can download it from here. I already downloaded the Orange Data Mining software. You can see that. Okay. In here, you can see that there are lots of widget here, file widget, transform and visualization widget, models and evaluation widget, or etc. Okay, if you're not familiar with coding, you can just simply drag and drop your algorithm or design to perform the operation. For example, I drag on the file. In here I am using an example. Here I am using an example to classify diseases based on the symptoms. Okay, classification diseases based on the symptoms. So I have some symptoms, and based on these symptoms, some classification also there. So I have a data set here for that. You can see that this is a sample data set with some symptoms and diseases. Okay, 16 data. Okay, so I'm using this data set due to create an algorithm to classify the diseases. Okay, so I am dragging the file widget, and you can see that here you can upload your data set here. Okay, data, disease data. I already uploaded the data set, and if you want to select the columns, what columns can use to target and features. So select column is another widget you can use. Okay, in here just you can no need to code that, connect this CSV to select the column, just drag and connect, that's all, that's enough. Okay, so you can see that all the data from the CSV file and can be transformed into here. You can see that features have been listed and target is diseases. Okay, so I already done the categories. So then if you are using any machine learning model for your project, I'm using here logistic classification for the classification purpose. Here you can see that models, machine learning models like KNN, tree random forest, SVM, etc., etc. I'm using here logistic regression. So just drag the logistic regression widget, and you can see that I given a name LR. Okay, so just connect with this select column to logistic machine, and from that you can save that model here. I'm saving that model test.pk CLS. Okay, so you can complete the operation by drag and drop. From this, I'm loading the model for the prediction purpose. For prediction purpose, I am using the same data set, that previously used, without the target column, only using the symptoms. Based on the symptoms, this machine learning model to predict what are the diseases for the symptoms. Okay, so I am uploading. So I am loading the machine learning model here, test.pickles, and file here, file data set, disease data set without the target or the diseases. Okay, from that prediction we can see that prediction, the first data will be predicted flu, and the second flu, third COVID-19, etc., etc. Okay, so non-code users, you can use this platform to develop your machine learning model or algorithm. Okay. Okay. So these are for AI. AI-based simulation means AI-based model training, and that's all. Orange Data Mining, OpenAI, and Gemini Robotics, Google Collab. And now we are going for robotics-based simulations. Called the first tool is MATLAB. Okay, MATLAB. Okay, you can download from MathWorks. Okay, I already downloaded the MATLAB software. In MATLAB software, there's a special library or toolbox is called Robotic System Toolbox. It provides designing, simulation, testing, deployment, manipulator, and mobile robotic application. Okay, so I will show you some example. You can see that here is the robotic 2D simulation, arm simulation. Okay, using robotics toolbox. So we can see that the robotic arms and the link and effectors, how these have been moving, and the flexibility and all the operation can be done. We can simulate by using the MATLAB. This is a 2D simulation, and we go for next one. A-based means how a pick and place robot can be worked target based on the target. Okay. Can see that the pick and place robot, the moving object with their corresponding flexible movement and the end effectors and the mechanical arm, it will locate the object and place the corresponding appropriate place. Okay, so all the simulations, robotic simulations can be done using the MATLAB robotic tools. If you're a developer, coding developer, you can use this MATLAB toolbox. Okay, and you can customize all this. Okay. Then next one, if you are a healthcare organization or institution, you have to completely integrate your robotics AI with your institution or organization. Okay, then you can use for NVIDIA Clara. NVIDIA Clara is a AI for personalized healthcare. It has some predefined framework. It have all framework and pre-trained model and tools for medical imaging, genomics, and drug discovery. It enables researchers to run, build, and deploy AI models and diagnosing images, smart hospital monitoring, everything. For the hospital automation purpose, for every tool is inside the NVIDIA Clara. Okay, NVIDIA Clara is support AI for healthcare and also the life sciences. One of the tool called Clara Holoscan, it will rendering the multi-organ for radiology and radiation therapy. Okay, so you can develop your organ simulations, something like that, using the Clara Holoscan. Okay, so let go to deep into the NVIDIA Clara. Okay, and the first one is BioNemo. BioNemo is the one of the main AI tool in the NVIDIA Clara. Okay, it supports. You can see that. I will show you. You can see that BioNemo has large amount of digital biology research library. Okay, it has plenty of research libraries integrated for the robotics purpose and healthcare software. Okay. The next one, Nematron. Nematron is a large language model. Okay? Nematron is a large language model to training your robot to understand complex medical terminology. If you are using robotic system to integrate your complex medical terminologies and chart, you can use for LLM. That means Nematron. Nematron in NVIDIA Clara, you can train the robots for complex problems. It will analyze and provide all the frameworks for the anatomy or complex medical terminology. And next one, MONAI. MONAI is a medical open network for artificial intelligence. Okay, it will training robot to recognize organs and tissues in real world video feeds. Okay, so if you are trying to use robot for surgery or organ identification, whatever, okay, this process or this scenario, you can use Mono AI. Okay, Mono AI is a anatomy segmentation process, training robot to recognize organs and tissues in real-time feed. Real-time feed you can process using this Mono AI provided by the NVIDIA Clara. Okay, and the next one is Act for Healthcare. Okay, it is a complete hospital automation AI software. It will integrate all these into a single bundle and control all the hospital operations and all the details into a complete automation purpose. Okay, so it is interact AI AI robotics interaction and with human patient in a virtual world. Okay, that means you can create a robotic how a robotic behavior with a human. Okay, that will be created by in a virtual world. Okay, so you can test and simulate these scenarios in Isaac Healthcare AI. Okay.
Jiten sir, can you please put it on presentation mode?
Okay, ma'am. Okay. The next two important two platforms are Holoscan, SDK, and Parabix or Parabix. Okay. Holoscan SDK in the processing real-time data for the surgical cameras and for immediate AI feedback. It can be create an hologram of the organs or multi-organ system for the radiological department. So for that, and the Parabricks is an accelerated genomic data analysis for the personalized robot treatment. If you are using personalized robots, then you can use the Parabricks AI integration. So it will create a data analysis to personalize the treatment for that. Okay. These are the tools provided by the NVIDIA. And next we are going for simulation software like WebBots. WebBots is an open source and multi-platform desktop application. It provides a complete development environment to model, program, and simulate the robots. Okay, it have plenty of library robots like Franca, Universal Robot, and ClearPath robots. Okay, you can if you are a developer or coding skill, you can use to develop or customize these predefined or library robots. Okay. So you can download the webboards from here, and I already downloaded. You can I will show you an example. Okay, this is the platform of webboards. Okay, here you can see that different samples are there. Okay, I'm going for the open body sample. The first one, Ukwa. Okay, Ukwa library robots. Okay, I will show you. It will be used for the surgical assistance and precise medicine handling. If you are customizing for that, okay, so you can see that it's already programmed to simulate the object picking, surgery assistant, precise medicine handling, like that. Okay. Okay. So if you have knowledge about the C programming language, then you can customize these options or means these operations or the robot. Okay. You can add or change the robotic operation and the movement and the kinematics, whatever you have to customize using the C programming language. If you are able to understand the C programming language, it will be easy for you. Okay. And I will show another example, Franca Emica. you are going for lab automation and medicine picking, then you can use this robot. So all the robotic environment you can simulate here. Okay, if any issues or regarding joint movement, whatever, you can simulate the environment here and you can test the environment. And after that, you can feed into the actual robotic, physical robotic system. Okay. Then I will show another example, universal robots. So you can see that universal robot for picking and placing, arranging, or proper arranging. You can use for the medicine, pharmacy automation, like that. Okay. And the last one, clear path robots. Clear path is for hospital delivery robots like that. Okay, so you can use hospital delivery something one place to another. Okay, so if you are knowledge about the coding or C language, you can customize for your scenario or operations. Okay, so Boots is the best simulation software for the robotics. You can customize all the joints and the operations and the environment also. You can change or customize. Okay. And the next one, Copilia Sim. Copilia Sim. If you're a non-code users, okay, you can only know the drag and drop method or the user-friendly environment. You can use the Copilot Sim. Okay, Copilot Sim is a powerful robotic simulator that allow you to design and test complex automation systems in realistic or 3D environment. Okay, you can just use the drag and drop method to perform the action or design your robotic system, and also you can integrate with the AI or some extra IoT or everything. You can integrate with this robotic system. It have plenty of, again, it have plenty of robotics library or robotic or predefined robotic system you can use to or customize for your healthcare operations. Okay, for example, first one, the Kukua yogurt robot. I will show you. This is the Copilia simulator platform. Okay, you can see that robots mobile type and non-mobile types. Okay, in mobile type you can see that there are plenty of robots system is already here. you can customize for your purpose. Whatever the purpose or the healthcare, you can use hospital delivery robots or surgery or whatever the patient rehab and assistance. Okay, you can use that. Okay, and perform the simulation here. If you are okay with the simulation or testing of all are okay, then you can convert it into the physical real world environment. Okay, so I'm using the your yoga robots for your purpose. Here you can see that this I drag this Kuka yoga robot and will show you the working. Okay, you can use for the delivery robots like that. We can place the medicine and transfer one place to another. Okay, here you don't need to know about the coding. Okay, only need the logic or the basic machine learning or robotics concept. Okay, if we can add or customize these using, we can add something like camera, light, or graph, or proximity sensors. Different sensors are there, vision, force sensors. Okay, you can just click that if you need it. It will automatically align with the robot. Okay, I will show you some example. The next one, is UR5 robot. UR5 robot from the non-medical, non-mobile section. It's a robotic arm-based. Okay. It's like a manipulator. You already seen previous slides. It's like a manipulator to perform the task. You can see that movement. Okay, if you want to add some extra sensors or components, you can add here. I'm adding to a proximity sensors like cylinder type. Okay, then again you want to add another sensors. Cylinder type already added. Okay, okay, DCC. Okay, then I will show you another example. Z, UPA, LBR, and ABBIR. Okay, ULBB, BR. Okay, you can see that. Okay. So you can customize the manipulator for your robotics purpose. Okay, so these are the tools, all the tools used for the robotic simulation. Okay, so the back to slide. Okay. So we can use webboards and Popular Sim for the robotics simulation. We are using webboards. You can little bit knowledge about the C programming language or the programming any programming language. If you are using, if you are not familiar with the coding, you can use for Popular Sim. Okay, and Zach Healthcare. Okay, and this total summary: the Google Colab and Gemini Robotics and OpenAI models, then Orange data mining, and These are the AI-based software for developing your AI models for your robotic system purpose. And MATLAB. From the MATLAB, we can simulate the robotics environment. Okay, MATLAB, and also the NVIDIA Clara. NVIDIA Clara, there is a lot of Neutron, Monai, and Isaac Holoscan Parallax. So you can use NVIDIA Clara for your hospital total management or hospital automation, complete automation. You can go for the NVIDIA Clara, or just a project or simple purpose, or you can develop your own robot system or project research process. You can go for Weboots and Copilia. Okay, Weboots given customizing through the coding and the skills, or if you are not familiar with the coding, you can go for the Copilia. Okay, so Copilia also giving the 3D structure for the hospital robotics visualization. So all these tools you can use for the healthcare robots to develop. Okay. Then, with these technologies in place, let us look at the future. Okay, especially in India, rapidly emerging as a strong player in healthcare robots. Okay, key highlights are around 20 compound annual growth in medical robotics, 30 plus 300 plus surgery robots are installed, and 60,000 plus robotic surgery per year annually have been done. Okay, and also integration of AI with robotics enables smart diagnosis and autonomous hospital workflows and real-time decision making. Plus AI plus IoT will give you intelligent connected hospitals that support Industry 4.0. Okay. So to conclude, AI-powered robotics is transforming healthcare and enhancing precision in surgery and supporting patient rehabilitation, automation, and hospital operations. And the future lies in intelligent, connected, and autonomous healthcare system. However, along with the innovation, we must also focus on ethical consideration and data privacy, human AI collaboration. Not only with the AI, with AI and human collaboration, we can done integrate. We can go for many features. So with that, I conclude my presentation. I hope this session provide valuable insight into the role of AI in healthcare robots. I would be happy to answer any question if you have. Thank you.
Thank you, sir, for that informative and engaging session. We will now proceed to the question answering session. Participants may kindly post their queries in the chat box or raise hand. Dear participants, if you have any queries, you can interact with the resource person. There is a question in the chat box. Can you see that, Jitin?
Okay, let me see. Any diabetes simulator available, publicly available other than the UAV and photo. Okay, okay. You can use Bluecova NVA, real RL friendly simulator. Okay, for this purpose. Okay. And it has Python. It has Python based. Wait a second. 1 second. Okay, it is a Python-based reinforcement learning control, and you can use Glue Power NVA as a friendly simulator. Okay, then next question. Any other question?
I think there are no more further questions. Let us move forward. So this is another question. I think another question came.
How precise will be the robotic surgery considering the health constraint? The precision. Every robotic surgery have some limitation. It's also the precision. Actually, we are developing AI or integrating with AI with robots, but it has some technical default. Then that can be handled by our AI. So AI system can be integrated with a robotic system. Robotics, we can uh, avoid or prevent the some issues regarding the technical faults.
Okay, on behalf of the organizing team, I would like to extend my sincere thanks to our resource person, Mr. Jidin Casey, for sharing his valuable knowledge and insights. I also thank all the participants for their enthusiastic participation and interaction. Kindly take a moment to fill out the feedback form shared in the chat. Thank you all once again. We will be starting the second session shortly. Please stay connected and continue listening.
Thank
The
you.
second session will begin within 5 minutes.
Kindly send the feedback link in chat box. If you select it, not open, ma'am.
Also, kindly once again announce that tomorrow the second section will be in Teams. Please make announcement again.
The chat box is open. You can post your queries there. I think the queries are coming. Okay, regarding the tomorrow sessions, that will be conducted through Microsoft Teams. Participants who are joining through the mobile phones can needs to install the Microsoft Teams app in advance. Those who are joining through desktop or laptop can join directly through the web browser. Okay, I think the message is clear. Tomorrow's second session will be conducted through Microsoft Teams. So, participant who are joining through mobile needs to install the Microsoft Teams app, and those who are joining through desktop can join directly through the web browser. Okay, this is regarding tomorrow's second session.
1 to 2:30 will be normal Zoom. Then 2:30 onwards, it will be Microsoft Teams.
Dear participants, if you have any queries, as we already announced, we will be share a document with you. You can post your queries there. And in the last session, we have a panel discussion. You can interact with all our resource persons there. Okay.
If you have any specific questions, please fill it.
Welcome back, everyone. I hope you found the first section insightful. We now move on to our second section. The FDP program is organized by the Department of Artificial Intelligence and Data Science on the theme AI in Healthcare, Data Analytics, Ethics and Real-World Application. It is pleasure to see such a enthusiastic participation as we move into the third day of this FDP, continuing our journey of learning and knowledge sharing. This section is on healthcare datasets of healthcare, data in research and clinical practice, and give a brief overview of datasets and repositories. It also focuses on their role in data-driven decision, AI application, and the ethical and secure use of health information. The session is important as it helps us understand how healthcare data can be effectively used to improve patient care, support research, and drive innovation in AI. We are honored to have our resource person, Dr. Vinay Modam, MD, MS, Texas, USA, a pediatric ICU physician at Cook Children's Medical Center, Fort Worth, and serves as an associate professor of pediatrics who brings valuable clinical expertise to the section. He has extensive experience in pediatric critical care, along with strong research expertise in artificial intelligence and machine learning applications in healthcare. His work focuses on clinical decision support, time series data analytics, analysis, and interpretable AI in high-stakes medical environments. With numerous research publications and contribution to the field, he brings a valuable blend of clinical practice and advanced data science knowledge to this session. We are truly privileged to have such an experienced and knowledgeable expert, Dr. Vinay Modam, with us today. Without further delay, I invite him to begin the session. Sir, you can start the session now.
Good morning, sir.
Thank you, ma'am.
Welcome, sir.
Hello, Dr. Lam. Thank you. I sincerely appreciate the opportunity to be able to present to a group of data scientists. I'm very excited about the collaborations between healthcare and data science. And it's been my interest for the past at least 3-4 years to learn more about data science. And yeah, I'm currently a pediatric ICU physician at Cook Children's Medical Center. So I have faculty affiliation with TCU School of Medicine. So we have medical students who come and spend time with us as well. Yeah, so for one thing, I apologize for not informing ahead of time, but I kind of assumed I'll be talking about data types today, data types and challenges instead of data bases. So I'll do the databases tomorrow. So the focus today will be data types and challenges. Let me share my PowerPoint.
Yes, sir, visible. Please go ahead.
Okay. So just to kind of apologize ahead of time, I really took liberty at using Gemini to generate a lot of graphics. So most of my presentation is going to be a lot of Gemini graphics. I was just trying to play with it and see how I can optimize the visualizations generated by Gemini by using the right prompts and stuff. So this graphic basically is just to kind of show you the environment I work in. So I take care of sick kids in the ICU setting. So one of the things with ICUs, patients generate a lot of data. So as clinicians, physicians, surgeons, we have to look at this data and process the data and make critical decisions based on this data. So that can potentially impact survival of some of these patients. So data is very important. And there's a lot of technology as well in the ICU setting. As you can see in the graphic, so many monitors, a lot of machines around the patient. So it's a true collaborative environment. And data scientists definitely play a big role in a lot of ways. So without information technology, it's very hard to take care of a patient nowadays because we are very much dependent on computers in terms of following labs, vitals, trending things, writing notes, putting in orders for medications or treatments or therapies. So everything involves technology. So this is a typical environment. So, again, like I said, I was playing with Gemini. So I just asked Gemini to kind of describe my academic journey, and it came up with this graphic. Just to kind of give a little bit of an idea, I started off as an engineering student, and after completing 1 year, switched over to medicine. But some of the basic analytical approaches I learned as an engineering student stayed with me throughout my career, and the math background that I obtained during in first year of engineering and the analytical approach has been a major part of my career. So I went to medical school in Bangalore, and once I completed medicine, I came to US for training, pediatric training, and I did a fellowship at University of Buffalo, and then came to Dallas. And since then, I've been in Dallas area. So as I mentioned, my primary affiliation is with Cook Children's Medical Center. I'm an attending physician there. And I also have faculty affiliation with the medical school. So I get to teach students and mentor them with research projects and things like that. So I started my career with interest in clinical research. So clinical research is very messy because clinical data is very messy. A lot of issues with interpreting clinical data, knowing the quality of clinical data. So those were major challenges. And as I evolved through my research career, I developed more and more interest in data science. And fortunately, I'm at a stage in my life where I have time to be able to get some more knowledge. So I'm currently a graduate student as well, working towards master's in data science and hopefully PhD in data science soon. So just to kind of give a general idea about my research interests and how data science connects to my interests. Currently, these are some of the projects I'm working on. So a lot of them involve big data, especially when we are modeling ICU outcomes. We are looking at multimodal as well as high dimensional data sets. And we are developing more and more collaborations in terms of putting data together between different hospital setups. So we are able to develop multi-center databases for research purposes. So essentially, that makes it large. And on top of that, genomic data. So genomic data is a huge component of big data for healthcare. So all these come with their own challenges, but that definitely makes data science a prominent part of modern clinical research. So for this talk, my learning objectives, just wanted to introduce clinical and biomedical data types, just give some basic idea about the different characteristics of different data we encounter, and maybe talk a little bit about the issues with this data and how do we overcome these challenges. If we have time, I would like to show at least one of my projects just to kind of show how managing data is a collaborative effort between data scientists and clinicians and researchers, because domain knowledge is very important in utilizing this kind of data. So the center of clinical data science is clinical data. It has 5 components to it. So 5 dimensions to it. So number 1, obviously, patient generates the data. So the next big component is the parameters we are looking at. The parameter we are looking at, which type of data generated by the patient are we interested in. And it's very important, especially in healthcare. We need to know how that data is being measured. How is it being quantified? How is it measured? What kind of units? So all those things make a big difference in terms of how we use it in research. Of course, value is important. And a lot of these data have a temporal sequential component to them. So they are generated at different time points during patient's longitudinal course in the hospital or outside. So time sequence is another big component of clinical data. So what do we do with this data? Data is just data. So it is bland. It doesn't mean much. So when data becomes information, it is carrying a message. And when we are able to transcribe the message, it becomes knowledge. And once we acquire knowledge about something, we can potentially use that to do something to help the patient, make things better for the patient, hopefully. So data is, the quality of data is very, very important because, as you can see here, garbage in, garbage out. So the information that we obtain from bad data is actually more dangerous than no information, because it can potentially direct the clinician to do things that may harm the patient. So it is a key component. The messy clinical data, understanding that data, knowing what the data is, what are its characteristics, what kind of, so basically exploratory data analysis in the beginning is almost 90% of what AI and machine learning can help us with, even before we get to the algorithms to analyze the data. So algorithm is probably, once things are cleaned and set up, it's pretty simple. So once it's generated, it generates some useful knowledge. That knowledge is pretty much immediately used by the physicians to make decisions, and we see results in terms of patient outcomes. So that's the process. So how is this data generated? So if we buy a car, we know everything about the car upfront. So we know what kind of mileage it's going to give. We know how fast it can go. So all the components that are important to describe that car. But with a patient, it's different. So patient data generation is sort of a sequential and recursive process. So patient comes in with a problem. So the physician comes up with some potential hypothesis for his problem and is going to start asking more questions to exclude some of the possible hypotheses and then iteratively comes to some more definitive diagnosis, and maybe will get a physical exam, will order some labs, will order some radiologic studies, X-rays or CAT scans, will do some waveform type EKG, ECG, or EEG, or anything of that sort. As you can see, as the patient goes through the process of getting a diagnosis, is generating sequential data, and every step, there is additional things added to the data, characterization of that patient. So eventually you come to a diagnosis, and then hopefully you come up with the right treatment for the problem, and patient gets better, or maybe patient doesn't get better or goes into this chronic cycle. So, but essentially, this is the life cycle of data. So what are the different sources of data? Like I mentioned, the genomic data is becoming a big component. Basically, we are able to understand at a cellular level, at a gene level, how we can look at activation of specific genes and associate with phenotype. Phenotype is what manifests outwardly. So in terms of clinical symptoms, or the way the patient is feeling, or in terms of labs. So we are able to tap into this genomic data and look at the activation of genome to connect it with or potentially predict future course of the patient. In addition, another big component that is added to traditional data is, everybody has cell phones. Everybody generates, a lot of people have apps on the cell phones that monitor their blood pressure, or maybe the heart rate. They wear smart devices that again generate a lot of data. So these are some of the things that traditionally, as clinicians, we were not used to having this information, but now we are getting all this data, of how the heart rate varies throughout the day when the patient is at home or at work, or, so typically physicians don't get to see a patient when they're at work or at home. But now we are getting that input. So now we need to learn to use that information. The heart rate or blood pressure when the patient comes to the doctor's office is one snapshot of the lifespan of the patient. So it is not very helpful. So now we are learning to integrate all this into healthcare data and learn to use it. And Internet of Things, there is more traditional medical records generating data, medical images generating data. Oh, the other new component is the social media. So it's amazing how sensitive social media is in terms of picking up what we can expect. So like I said, I work with kids primarily, so teenagers all the way up to 18, 20 years of age. So we hear things about some TikTok challenge going on about doing some foolish thing, and they end up in the hospital. And one patient comes, then we have 5 patients coming in with the same complaint, because they all are doing the same thing. So it is a very sensitive indicator as well of what's going on in terms of health out in the community. So a lot of data sources. And data generation happens at different places. So in an ICU setting, in a hospitalized setting, there is certain type of data. There is a lot of lab data, a lot of continuous vital sign monitoring, a lot of physical exam data, uh, uh, maybe a lot of X-rays, a lot of monitoring waveform data. So all these things have a specific characteristic in terms of the data input for hospitalized patients versus a patient that's at home and comes to the clinic. They generate different kind of data because they're not constantly monitored, but wearable sensors and things like that become an important component of data generation. And at public health level, we all went through COVID. So COVID kind of really generated interest in using this public health data at a big data level, essentially. So it is very interesting how, for example, on the right-hand side, you can see epidemics, how they're picked up. Public health agencies are monitoring a lot of things. So some of the things that are not in this infographic, for example, they monitor things like if a lot of people are calling in sick, are absent at work, or buying a lot of paracetamol or ibuprofen at the pharmacy. So all those are sensitive indicators of something going on in the community. So they may be the first signs of the next pandemic starting. So all of this needs monitoring of data, proper processing of data. So that's the difference in different settings. So that's as far as different sources. So it's very hard to go into all the sources, but just wanted to kind of point out it is so heterogeneous. The data sources are so heterogeneous. The quality is so different. The type of data is so different. So that kind of makes it really challenging to process this data. So at high level, we can categorize healthcare data into two groups. Structured data, structured data is wonderful, at least in concept, because it is most of the time it's numerical, but it could be categorical as well. But at least you can rely on the quality of the data to some extent, and it comes with clear, well-defined, timestamps or all those things, units and things like that. But structured data is only 30% of the healthcare data. So majority of the data that we deal with is unstructured data. So unstructured data needs processing to convert it into something quantifiable. So something that could be vectorized so it can get into a machine learning model. So processing this, NLP is one of the big major tools that plays a big part in processing a lot of this data. As NLP techniques get better, I think we are able to harness this unstructured data much better to our advantage in terms of analysis. So, like I said, unstructured data is the bulk of clinical data, a lot of notes. They do have some structure, but majority of the clinical notes is very much clinician dependent. Who is writing the note? Is that nurse very busy and is not able to document because the patient is really sick, or is not documenting much because the patient is really doing okay, so it doesn't need much documentation. So it is again very hard to rely on this. So reports, all kinds of reports for imaging studies or ECGs or labs or pathology reports, all these things kind of contribute to that. Add to that, and image data is a big component. So we have definitely made a lot of advances in image data in terms of harnessing the power of AI and machine learning, neural networks and all that stuff, deep learning. So it has made a huge progress over the last even 10, 15, 20 years. So like I mentioned, it requires NLP and image processing and things of that nature to move forward. So this pictograph is basically looking at numerical data. So, seemingly the easiest data to work with, but still a lot of issues. So inconsistent standards and units. So blood sugar in US versus in India versus in UK has different units. So, and they're very different by an order of magnitude. So it makes it hard to kind of interpret that when you don't know what the units are. And the quality of the data, missing data. Does missing mean patient was not sick enough and that's why nobody checked that? Or is the patient so sick that, didn't have a chance to check something? So those kind of things become a problem. There is some of the data that's generated primarily for billing purposes, ICD-10 codes. I think they're universal codes that categorize diagnosis and procedures and things like that. They are also numeric codes, but they are truly not numeric because they don't behave like numerals. They are more categorical. They are just numbers, but they are categorical data. So yeah, so these are all challenges even with numeric data. So we'll see how to kind of manage some of these challenges in the next few slides. So I mentioned about the diagnostic data, ICD-10 codes, procedure data. So these systems were primarily developed for billing. So they have high level of granularity. So for example, there are almost 80,000 different diagnosis codes and 80,000 different procedure codes. When we are dealing with this kind of data, it becomes sparse. If there are so many different diagnoses, the number of patients with a given diagnosis become very few, even in big data sets. So we need to figure out how to deal with that situation. So that's one of the things that, yeah, so like I mentioned, so on the left, it's talking about sparse data, sparsity, and over specificity. And primarily, like I said, these are made for billing. So they may be sometimes not truly reflective of patients' severity of illness. So it's more focused on reimbursement. So all these make it a little bit more challenging. But the positive for these ICD-10 diagnosis and procedural codes, at least every patient will generate certain ICD-10 codes. So at least that there is some information about the patient. So as opposed to manual documentation of what is going on with the patient, this gives a ballpark idea of what the patient's diagnosis is and things like that. Yeah, same thing. It's just looking through all the different challenges with ICD-10 codes, granularity, sparsity, semantics, mapping issues. Different centers may have different coding practices. So one hospital may code a patient with a certain diagnosis, and the other hospital might code the same patient with slightly different diagnosis. But that's still because of the granularity, it makes it challenging to group them properly. Yeah, so a lot of issues there. So there are some ways to mitigate this. One of the ways is, for example, phenotyping. So you club certain groups of ICD-10 codes into categories, so that way you don't lose the big picture, and you address this sparsity issue. So collapsing some of the codes into specific groups, and learn to not just look at the group, but use embedding, for example. Use a neural network to learn proper embedding for a given ICD code. So that way, it is vectorized appropriately, and um, it carries more meaning. Yeah, so those are some of the things with ICD-10 codes. Again, dimensionality reduction techniques are important. So I mentioned most of these. We use starting with classical dimensionality reduction techniques like PCAs and autoencoders, more advanced methods like RNNs, temporal CNNs, transformers. So all kinds of ways to decrease the dimensionality. So that's diagnosis data. So now the big component is the time series data. So a lot of data that's generated by these patients, like I mentioned earlier, it is sequential. We look at a patient's heart rate and blood pressure multiple times at different time points. So same way we do labs at multiple time points. So this pictograph basically is just showing, for example, at the top, you can see sequential values for heart rate in blue. Then you can see red is probably the blood pressure, and green is probably the respiratory rate. So you can trend. So two component state. So one, of course, what is the patient's baseline value, and a lot of times it's not just one time point. Variability of the heart rate, for example, or variability in blood pressure is a big component as well. So we are able to see that when we have this kind of sequential data. Same thing with labs. So this second block is for labs. Third block is for some of the support we are providing to the patient. For example, mechanical ventilation, oxygen. How is the patient doing in terms of coma scale? All those things sequentially mapped. And here it is showing timed medication doses, what time the patient got the medicine, how did the patient respond to the medicine, So we are able to see that and this kind of visualization really helps figure out what works for that patient and what doesn't. So this is the fluids and nutrition the patient is getting, any therapies the patient is getting, like if patient has kidney failure, is the patient getting dialysis at certain time, things like that. So all these are time series data. So we have so many sources. The big question is how do we robustly fuse this multimodal data. So that is the challenge, and that's the focus with healthcare data types. Yeah, same issues with imaging data. So we have to quantify the imaging data. So a CAT scan, even though we look at it as clinicians, but truly it's not the picture. It's basically a bunch of numbers. So clinicians don't see that aspect. So the way the numbers are processed will impact how the image looks. And as we learn more about the imaging data, we are able to identify things. For example, some of the patients may have problems with metabolism. They don't know, they don't have the mechanism to process certain nutrients, certain proteins, for example. And when those kind of proteins are not processed properly, they cause certain changes in the brain that can impact that is not visible immediately by traditional CAT scan, for example, but PET scan or something along those lines can actually give us more information about whether that particular chemical is accumulating in the brain in certain areas, how it's impacting the function of the brain, things like that. So all of this is data science dependent analysis. So the other counterpart for imaging, waveforms. So again, sequential data, a lot of high dimensionality and a lot of noise. So those are the big characteristics. So one of the newer things that we are incorporating into, so we used to talk about evidence-based medicine. So basically what evidence-based medicine is we give a treatment to 100 patients, and if 60 patients do better and 40 patients don't, we say it's a success for that medicine. Okay, so we say, oh, it works in 60% of the patients, so we just use it in everybody. Now we realize not every patient is the same. So from just pure big picture evidence-based data, evidence-based practice, we are moving towards what is called as personalized care, personalized medicine. So a big component of personalized medicine is their genetic composition. So that's where all these omics, we call them omics because they all end with OMICS. So genomics, epigenomics, transcriptomics. So they're all components of what happens at the cellular level. So the way it works, genes are activated. So when they're activated, they're transcribed to produce certain proteins in the cell. So these proteins act as enzymes, and so these enzymes are the ones that run the cell machinery. So if certain gene is activated for some reason, a patient has fever, for example, certain gene gets activated, and patient starts producing certain proteins that can fight the infection and fight the fever-causing infection, for example. So we are able to pick up those things. So we are able to, for example, COVID, certain protein production increases. So we are able to see how bad the response to COVID is in that patient based on measuring these concentrations in the blood. So metabolomics is basically further down. So these enzymes do things in the cell, and as a result, certain metabolites are generated. So we see that. And microbiome is another interesting area. So where we all carry certain bacteria in our gut, on the skin, in the back of our throats. So they are called normal commensal bacteria. Some of them are good bacteria. In fact, we eat yogurt, so we can have good bacteria in our gut. So it prevents bad bacteria from growing. So that keeps them under check, so we don't get into problems with stomach upset and stuff like that. So knowing the microbiome is also important. So all these are called omics, and this is another big data component that's being added to healthcare data. So this helps with moving from evidence-based medicine to uh, um, personalized medicine. So, just because the neighbor had the same fever, got a certain medicine, doesn't mean you should get the same medicine because you have the same fever. So it may be different response in you versus the neighbor. So that's what we want to understand from all of this. Let me just skip that. Yeah, so this is digital health and Internet of Things. How we integrate information coming from all these different sources. So that's another challenge that we need to figure out nowadays. Physicians sometimes directly get information from uh, uh, a patient who is wearing a certain device that is monitoring the patient. For example, it's monitoring their heartbeat, and if there is irregularity, it comes as an alert to the physician's phone, so they'll be able to respond to it right away. So those kind of things are happening. So how do we use this data with um, we are learning. So because this is a lot more data than we were used to, so it's good, but we need to first learn to interpret this data. So that becomes a challenge. Yeah, so multimodal, integrating all that into harmonizing all that data is something that we need to work on. Yeah, I think that's basically as far as uh, data sources and the different types of data is concerned. So I think we can, if you want, we can take a break for 10-15 minutes and reconvene. So there are a few more things I want to talk about. So how do we deal with all the issues that I just mentioned when we are analyzing this data is what we can talk about. Any questions so far? Anything I need to clarify? Looks like there's a question about juvenile diabetes management. Yeah, I think again, like many things, we were not used to monitoring glucose in real time continuously. So we were used to looking at blood sugar, we would talk about fasting blood sugar, uh, fast overnight and come in the morning and check the blood sugar. And that's how we define diabetes. So now we are learning to use this continuous glucose monitoring. I think it is well defined, and it is definitely playing a big role in management of especially teenage patients. So a lot of these patients are wearing insulin pump, so that directly communicates with uh, uh, these continuous glucose monitoring devices. And so it does adjust the amount of insulin being delivered to the patient uh, based on the blood sugars. So based on how their eating habits, and also patients have control on, for example, if they are going on, they're going for a marathon run, they indicate that, and in response, the glucose, insulin pump adjusts the amount of insulin delivered to the patient. So it is definitely playing a big role, and it is helping pediatric patients for sure. I don't know if that answers your question, but yeah, from ICU perspective, so glucose monitoring, especially in pediatric patients, uh, uh, we used to think that controlling blood glucose in sick patients is very, very important. But what we realized was by by overly controlling the blood sugar, we were making these patients hypoglycemic with low blood sugar. And we realized, that's a lot more dangerous to the patient, because as it is, the patient is sick, the brain is sick, and on top of that, we drop their blood sugar, uh, uh, they really get hurt from it. So because of that, um, we don't control blood sugar so tightly. We still monitor the blood sugar, but in terms of needing AI-based glucose control, um, we are not there yet. But that being said, I think learning to monitor glucose on a continuous basis to see how variations in glucose levels, uh, the variability, as well as uh, the level of glucose control, how does it impact outcomes? So that is something that we need to learn in terms of outcomes. So that is actually one of the things that a lot of clinical research teams are working on, figuring out what is the effect of glucose control. On the other hand, outpatient, not in the ICU setting, but outpatient glucose control, I think AI-based systems will probably play a major role, especially the type of diabetes that children have. Uh, they need insulin. So the need for insulin, our body produces insulin, so it knows how to regulate the amount of insulin that it needs to produce if we don't have diabetes. But patients with diabetes don't have that regulation, so AI systems have to learn the regulation and probably control. So there is good evidence that AI-based systems for glucose management, insulin pump management are very helpful in making these patients better. Did I miss any other questions or comments? Select there's a question from Dr. Radhi Krishna. How many iterations are decided in data analysis? So is that in terms of data collection for for these patients? I'm not sure what the exact question is. Maybe in 5 minutes we can get back on. Okay, so looks like there are 2 more questions. Challenges regarding data collection for centralized data with biometrics. So I'll tell you, one of physicians in general are a very conservative group. They don't want to try new things until it is very obvious that it's the right thing to do. So for the same reason, I think any new technology, any kind of biometrics that is new, it takes a while for it to be adopted. So that's part of the challenge that I think technology faces in healthcare setting. And second issue, I think, is patient confidentiality. So that plays a big role in the kind of data we collect and how we monitor the data. So there is so much data sitting there, but nobody has access to it just because of all the regulatory constraints in getting access to that data. So that's part of the issue, I think. But I think in general, healthcare systems are realizing the role, AI and technology is playing in growth, especially I think one of the biggest positives, as bad as COVID was, from COVID is I think we realized how important it is to share information and uh, collect good quality data. So I think it is helping. As far as AI bias, Dr. Nagana talked about AI bias yesterday. So the problem with data sets we have, there, there is involuntary bias in some ways because if I'll give you the example of US. You know, Caucasians, white people obviously are a majority. So most of the data that's collected is representative of Caucasians. And we are making we are interpreting or we are thinking we are gaining knowledge from analyzing this data without realizing the data we have is biased, maybe involuntary, maybe for a reason, certain minorities don't get well represented in the data that's collected. So for various reasons. So that does impact outcomes. So just to kind of give an example, so one of the studies looked at the fact that African Americans did poorly, in terms of outcomes when they had COVID, as opposed to Caucasians, and just looking at it with a detective eye. So we realized, the pulse ox, the device we use to measure oxygen levels in patients. So when the engineers developed pulse ox machine, it was primarily developed in European countries with essentially primarily light-skinned people. So this is a light penetration dependent measuring device. So it was involuntarily biased towards giving a better measurement of oxygen levels in light-skinned people as opposed to dark-skinned people. So, some of the studies have looked at how there was a delay in identifying how sick African American patients were with dark skin, just because not that they did not have their oxygen levels checked. It's just that the machine itself was developed without knowing there is an inherent bias in it. So that is the issue with with the current data. So that's why I think it becomes very, very important to really be very critical about any kind of disparities in the data. And how do we, more important, how you cannot generate data that's not, well, you can. So that's what you need to think about. So how do we make up for disproportionate or biased data? So how do we account for that? So there are so many techniques. So but first step is to recognize that there is a problem with the data set. So that's one of the things that's been a topic of research and discussions in conferences, at least in the medical setting. AI bias. I don't know if it answers your question, but that's my viewpoint. Can I go ahead with my presentation? Any other questions? Okay. Just for fun. So how much of healthcare data is unstructured? Yeah, exactly. So 70 to 80% of data is unstructured. So it's important to recognize that. What makes data difficult to use? Yeah. So we'll look at some of these things and how do we get past it. So that's the goal for the second half. Yeah, just to kind of go back and remind. Yeah, so we talked about different data types, biomedical clinical data types, and their characteristics. So now we'll see how it causes problems and how do we overcome those challenges. So data is very valuable. So it is complex, it is messy, but it's very valuable. So translating this data, this complexity for AI, so it can make right interpretations without AI bias, inherent bias because of the data quality is very important. So there are a lot of obstacles, missing values, poor quality, entry errors, basically missing values. So how do we address those things is the question. So data quality results from various reasons. So maybe duplicate entries, inconsistencies with the entry, data entry errors, outliers, and missing data. So all these eventually lead to missing data, essentially, depending on how we process it. So outliers, we need to be careful about how we process that, but depending on the situation. But a lot of this, one of the things I just want to kind of uh, um, restate is I think domain expertise, domain knowledge is important in how you handle missing data. So because there is missing data that probably has no clinical relevance, and there is missing data that has really significant clinical relevance. So I think there needs to be collaboration. So clinicians don't know what to do with missing data. Data scientists have the the skill to have options to deal with missing data, but data scientists don't know which missing data needs to be handled how. So that's the key thing. So this diagram here on the right basically is just going through different issues with quality. So intrinsic quality, so the data itself, maybe there is an issue with the accuracy of data collection, of the data measurement, consistency, completeness, how valid the measurement is, integrity of measurement. So all these things contribute to intrinsic quality. Then there is contextual quality. So is it relevant, at that particular situation? So if there is a baby crying, baby's heart rate is going to be high when the baby is crying. So we need to know the context. So it's not clear when you look at it on a spreadsheet, but that is relevant. So that is important. So understandability, timeliness, all these things, context is important. So resource related. So like I was telling you about dark skinned people and pulse ox measurement, they did not have the right resource. They did not have the right device to measure. So that limits the quality of the data. Accessibility, if it's a person who lives in a rural area without access to medical care, the measurements available for those patients are limited. And finally, all these things impact patient safety. So that is the key. So patient is the center of this universe. So patient safety is important. It has different dimensions. So yeah, so we talked about the intrinsic quality dimension. We talked about contextual quality, resource-related quality. So all these things, they basically translate to value of the data that the data is providing. Is it useful? Is it not useful? Is a question. So, and it's, like I mentioned, the previous slide, it's not just, oh, okay, data is bad, so what? But it's more of a patient safety issue. So it's not just a technical nicety, it's a safety issue. So that's what, because decisions are being made and treatments are being provided to the patient based on this data. So let's look at missing data. So in healthcare setting, there are different types of missing data. Different reasons why data is missing. So it could be missing because just random, truly random. So MCAR, basically. So blanking on the expansion of MCAR. Oh, missing completely at random. So basically that kind of data, we can handle it certain way. Then next one is missing at random. It's not completely at random, but at least for certain groups, it's missing at random. And missing at not at random. So that's the data set, the missing data that we need to be careful about. Because if it's missing not at random, so it's systematic. So maybe it actually means something. So that's why we need to be careful about that. So how do we identify, good EDA? Different ways to identify missingness. So that That's the key. So how do we handle what are the differences between these different types of missing data? So the completely at random missing data, so probability of missingness is the same for all observations. So missing at random, the missingness probability is the same within defined groups. It may not be in the general population, but at least in certain groups, it's missing at random. And missingness not at random, systematic. So we need to be careful about that. So dependency, missing data does not depend on any values. So for MCAR, whereas missing data for MAR depends on the group observed values. And not at random really depends on whatever is causing the patient to miss that data. So how does it impact data analysis? So MCAR does not bias the results if data is ignored. So especially if it's not a big number, or it's a lot easier to impute these numbers with some kind of central tendency metric, median, mean, whatever we use. So it's a lot easier. But for these, we need to account for the biases. So for MAR, we definitely need to take into account, is it only in women? Is it only in kids? Is it only certain men that are missing the data? So that becomes important. So missing not at random, so they cannot, they're definitely a group that needs to be handled specifically. Simple to handle for MCAR, requires some modeling for MAR, and it's most complex for MNAR. Yeah, so imputation, the way we approach imputation varies. So usually simple random imputation, more sophisticated methods, and really focused methods for this. Yeah, so how do we handle missing data? So deletion, simple, just don't count that patient. So remove the entire patient list-wise. So pairwise, only remove missing values for specific correlations. So it's still use the patient for other analysis, but only for when we are analyzing a certain column and that's the missing component, then we can ignore that. Variable dropping. So of course, if a column has greater than 25, 30, 50% missing values, then just drop that column, don't even count that. So those are simple techniques. Then simple imputation. So central tendency, mean median mode, that's easy. But it does impact the variance, so we need to be careful about that. Certain measurements, we just do last observation carried forward. So that's one approach. And certain other situations, we go for a little bit more sophisticated, some kind of regression or KNN to kind of come up with a little bit more educated guess for what value to replace that missing value with. Advanced techniques, there are special multivariate imputation techniques, mice. We can even use fancier autoencoders and transformers and things like that, and maximum likelihood. So those are some of the ways to do it. But it is, again, domain knowledge becomes important and how we handle missing data. So why do we care about missing data? So of course, it's going to decrease our cohort number, so reduction in statistical power. It compromises data integrity, misleading conclusions. So we'll have, overfitting issues, problems with generalizability, so ethical issues, bias. So all these are major issues with missing data. So what else do we need to do once we handle the missing data? Next step is, we need to do some data transformations. So certain data transformations to make sure our models are robust. So normalization and standardization are two ways we pre-process the data. So the purpose of this is to minimize impact of features that have numerically bigger values. Doesn't necessarily mean they truly have bigger impact on the outcome, but if they have numerically bigger value, that trumps something that has smaller value. So to account for that, we do normalization or standardization. So normalization is typically we talk about min-max scaling. So this pictorial really very nicely demonstrates that. So you're trying to keep it within 0 to 1 limits. So that's the good thing. So what kind of situations we use this? It's basically deep learning, neural networks, image data. So where we want bounded scale. Standardization. So here the goal is to try to get the mean to 0, but actual value could be negative infinity to positive infinity. So the value itself is not going to change, but the mean itself is going to try to get to 0. So that's the goal. And variance is going to be 1. So this is more important for regression type modeling. So we need to decide what kind of normalization we do based on that. So this one is just showing same thing, min-max scalar. And basically it's just showing what is the effect on raw values, their bigger range, and now everything is between 0 to 1 against ML models, linear regression. So same thing with standardization. Yeah, it's same thing. Okay, so next data pre-processing we do, categorical variables. So we need to do whether it's one-hot encoding or label encoding, depending on what kind of feature it is, if it is an ordinal or nominal. So those things matter. Sometimes we use frequency encoding. So the purpose is to convert nominal or ordinal data into actual numbers for data analysis. Then we need to look at transformations required to optimize the distributions. So if it's a skewed distribution and we want to do regression, we think about log transformations. Again, skewed distributions, certain skewed distributions, we need square root transformations, Box-Cox transformations. So a lot of these things are primarily for regression type analysis, I think. Some of the continuous data, especially, age is a common thing because with sick patients, age is never a in a sick sick patient cohort. Excuse me. Sorry, I apologize. It's 4 a.m., 5 a.m. in the morning for me. So age is one of the things that we may need to discretize or do binning, basically because it means more. For example, in pediatric age group, we have bimodal distribution for a lot of diseases. So we have patients who are less than 1 year, there is a big peak, and then there are very few patients in the childhood age group, and then teenagers, we have another peak. So those kind of patients, we need to appropriately bin them. Okay, so this is another place where domain knowledge becomes very important, feature engineering. So yeah, so a lot of data, a lot of elements. So, for example, the research project I'm working on right now had, I think, around 170 columns, 170 features. But eventually, we were able to collapse it down to 30 after feature engineering, we were able to collapse them down to 30, reduce them to 30 features. So big difference. For one thing, high dimensionality, we have curse of dimensionality issues. We need to be careful. And also, secondly, there is a lot of covariance, correlation between the features. And also, some of them actually make more sense when they're engineered into collapsed into a single composite feature. So basically, the domain expertise is helping get past some of the lower level features. So that actually helps with decreasing the number of patients we need for analysis. Yeah. So a lot of dimensionality reduction techniques, PCA, SVD, all kinds of things. So, but the goal is to minimize the dimensionality and time dependent. I know we are almost at the end of the allotted time. So, yeah, time series, we have to, I wish we had time to show some of the stuff, research that I'm working on, because it kind of exemplifies some of these issues. So maybe tomorrow I can probably spend a little bit of time showing some of that so it makes sense. But yeah, the way time series is handled becomes important. How do we aggregate, what kind of models we use? So all of those things matter. Same thing with waveform. How do we aggregate, looking at not just central tendency, but also looking at variability, variation is an important characteristic for a lot of these waveform type data. So we need to see how we harness that. So at the end, it's the same graphic I showed you earlier. So basically, we have a lot of multimodal, high dimensional data that needs to be processed and harmonized before it goes into a model. And doing the modeling is probably the easiest thing, once the data is properly processed. So I think that's where I'll stop. So any questions? Any comments about the Gemini generated graphics? I think they're a little probably overloaded, but I thought it would be helpful for people to go back and look at the PowerPoint when they have some time and look at these infographics. They definitely are rich with information.
Thank you, sir. Thank you, sir, for the insightful and informative session.
Thank you.
Now we will move on to the questions and answer section. Participants are requested to post their questions in the chat box or raise their hand.
I'm just curious, how is AI and data science and clinician collaboration in India right now? Is there interest in clinical research related to data science, using data science techniques and incorporating AI, clinical decision support tools, any of those things developing in India? It looks like we are at, it's time to end, right?
Dear participants, any queries? Please post it in a chat box. I think no more queries. On behalf of the organizing team, I would like to express my sincere gratitude to our resource person, Dr. Vinay Modam, for delivering such an insightful and informative section. Your valuable expertise has greatly enriched our understanding. I also extend my heartfelt thanks to all the participants for their active participation and engagement. Kindly fill out the feedback form shared in this chat.
Thank you. I appreciate the opportunity.
Thank you, sir.
Yeah, I'll join you tomorrow.
Thank you, sir.
Dear participants, we are already shared a form where you can drop your questions for
Thank you.
our panel members, especially if you were able to ask them during the session because of the time constraints. Already shared a form in chat box. One other thing is, dear participants, this is to inform you that tomorrow's second section will be conducted through Microsoft Teams. Participants joining via mobile are requested to install the Microsoft Teams app in advance. Those joining through a desktop or laptop may attend the session directly using a web browser. All of you, please fill the feedback form.
Good morning.